Hello! What's the best method for finding the equation of a straight line? We'll be finding that out, plus more, in today's Prove It. Right then, yes, we are here today to settle an argument once and for all, and it's an argument that's probably been raging on for years between teachers and students everywhere about the two main methods that exist for finding the equation of a straight line. I'm expecting everybody's familiar with what is ultimately one of the most popular formulas or formats for the equation of a straight line, which is y equals mx plus c. Popular, of course, because when you're looking at this equation, you can instantly just read off what the value of the gradient is from the m, you can instantly read off what the value of the y-intercept is from the value of the c, and then, because it's got a y equals at the front, that's more in line with what we generally do for a lot of equations of lines and curves anyway. But then what I'm talking about is the fact that some students like to use this structure of a line as part of their method for finding the equation of a straight line. I'm not talking about those situations where you're just instantly given what the gradient and the y-intercept of the straight line is straight away, because in those scenarios you don't really need any method, so to speak, because you instantly know where you need to place the value of the gradient in the equation, you instantly know where you need to place the value of the y-intercept, and so you can just jump straight to writing the equation of the straight line without any working shown. What I'm talking about are those scenarios where you're given a gradient and then the point on the line that you're given is any point on the line except for the y-intercept. In those sort of scenarios, students who use the y equals mx plus c method are having to adapt the structure to recalculate what the plus c is based on that information they're given about the straight line. Whereas some teachers like to use the formula for finding the equation of a straight line, which is y minus y1 equals m lots of x take away x1. Some students are stubborn though, and they refuse to use this new formula to find the equation of a straight line and stick with what's familiar. That's one of the reasons they decide not to change over to this new method, but the other reason that some students give for not using this new method is they look at it and just go, well, I don't understand how that method works, so I refuse to use it if I don't understand how it works. But secretly, that is a load of rubbish. Because secretly, whatever you have to do to y equals mx plus c, if you understand how that works, then you also understand how y minus y1 equals m lots of x minus x1 works as well, even if you don't realize it. And that's what we are going to prove in today's video, that they are doing the same thing behind the scenes. It's not one of those scenarios where you sometimes have two different methods doing completely different things that just happen to have the same end goal. These things are just doing the same things but presenting them in slightly different ways. But before we continue on any further, I must remind you, as always in this series, this is just a proof to help you understand what's going on with these methods. It's not a proof you need to know for the A-level exam. Okay, with all that said, what do we need to do this proof? Well, we just need to understand how the y equals mx plus c method works and how the y minus y1 equals mx minus x1 method works. We'll talk about that now, and actually we'll go through it in a bit of an algebraic way. So if we're looking at the y equals mx plus c format, how does that work? Well, we're looking for the equation of a straight line that's got a gradient of m and goes through a point that's on the line of x1, y1. So, we know the equation of our straight line must fit the format y equals mx plus c, but we need to find the value of that plus c. So, because we know the point on the line must satisfy the equation of the line, therefore we can plug those coordinates into the equation of the line to then see what's going on with the equation to make it work. So, we plug that in and get y1 equals m lots of x1 plus c. And from this, we can then find the value of the plus c by rearranging to get c equals. So to do that, take away m lots of x1 from both sides, so c is equal to y1 minus m lots of x1. Those are the numbers you're having to multiply, add or take away together to get your value of your plus c. Therefore, once you've got the value of the plus c, you can then place it in that structure of y equals mx plus c to get the equation of the straight line as y equals mx plus your value of the plus c, which was, as we said, y1 take away m lots of x1. So that's the first method. Pay attention to what we got at the end there, because now we're going to look at y minus y1 equals m lots of x minus x1. Again, equation of a straight line that's got a gradient of m and goes through the point x1, y1. The advantage of this method is straight away we can jump to writing an equation for the straight line. Not yet fully simplified, but we're given the information and the formula tells us where all that information's got to go. The gradient of the line is the m, the x1, the y1 go in their respective places. All we've got to do now for the rest of this method is just simplify the equation of the line. So to do that, we first might want to multiply the brackets. So we'll get mx, take away m lots of x1 on the right hand side, and then to make it y equals, we add y1 onto both sides, which gets, wait a minute, y equals mx plus y1 take away m lots of x1, which is exactly the same as what we got when using the y equals mx plus c method. We're multiplying the same things by the same things, we're taking and adding away the same things that we were before. All that's changed is just the order in which we've done things. See, although these two methods are doing the same thing, the y minus y1 method is better. And it's better because the way the structure of the method goes is you start off by writing the equation of the straight line in the correct structure and then spend the rest of the method doing the simplifying. The reason that's better is because you often, if you're going to make a silly mistake, you often do it as part of the simplifying stage. It's often the easiest maths where we tend to go wrong. Whereas the y equals mx plus c method is fully focused on doing the simplifying to find the single value of the plus c at the beginning before it then concerns itself with gathering everything together in one cohesive equation. So the problem is if you make a mistake as part of the simplifying with the y equals mx plus c method, you never had a correct equation at any point in your working. So anyway, I think the y minus y1 method is better. I'm not biased or anything, but there you go. We've shown they are doing the same thing, but the y minus y1 equals mx minus x1 method gets a correct equation if unsimplified earlier on in the working. Okay, hopefully now that's helped you understand how this stuff works. On the screen right now you should see some links to another video in the Prove It series, video in my other major series called Can We Do That? Do check them out. There's some really cool stuff in there, and I will see you in a future video in this series, I'm sure. Hopefully, goodbye.